An enigmatic entity that has been present since the earliest moments of the universe has taken the scientific community by surprise as it quietly emerged. Thanks to the remarkably sensitive sensors on the James Webb Space Telescope, scientists successfully captured the fleeting presence of this elusive phenomenon. Following the identification of the most ancient galaxy, astronomers have now detected a black hole situated near the outer edges of the cosmos. This is a supermassive, active, and oldest black hole with a massive equivalent to 10 million suns. This cosmic entity is ceaselessly growing by consuming matter from its surrounding space. Insights obtained by the James Webb Space Telescope's observations have unveiled this captivating event, shedding light on the extraordinary occurrence. What makes this colossal black hole so inspiring and unsettling? Is there a possibility that this massive entity will destroy the whole universe? Let's delve in and find out.
We see all this activity in the center of the galaxy, stars orbiting a big dark area. How do we know it's not just like the center of a hurricane? And the reason why we know that is because what we learned from Kepler and later Newton is the orbit that you have is the speed of your orbit is completely determined by the mass that's sitting inside your orbit. So what you say is, here are these things, I can see how fast they're moving, run back to Kepler's equation and say there must be a mass like bigger than the size of the orbit. And then you say, but wait a minute, we don't know anything that's that massive, that's smaller than the orbit, except for the black hole. This is dark and it has huge mass and it's small. That's 3 smoking guns right there, implicating a supermassive black hole.
The most plausible estimation for the appearance of the earliest stars and galaxies within the 13.8 billion-year-old cosmos suggests they emerged within the first 400 million years. Nevertheless, the precise moment when the universe initially flickered with starlight remains a puzzle yet to be fully unraveled. Among the principal goals of the monumental $10 billion James Webb Space Telescope, launched on December 25, 2021, was the accurate determination of the pivotal event marking the birth of the ancient era. Since its launch in the summer of 2022, the JWST has diligently conducted celestial surveys, scanning the skies with remarkable dedication. A recent endeavor of the James Webb Space Telescope involved peering 13.4 billion years into the past, revealing an astonishing glimpse into the ancient cosmos. An international collaboration of 80 astronomers spanning 10 countries has uncovered the 4 most ancient galaxies to date, including one born a mere 320 million years after the Big Bang. The image, when observed from a modest distance, appears as the size of a human, yet it is teeming with nearly 100,000 galaxies, each captured at a distinct point in their evolution eons ago. In a breathtaking visual journey, the James Webb Space Telescope documented these 4 ancient galaxies within the Hubble Space Telescope's ultra-deep field, an expanse hosting around 100,000 galaxies despite its modest size. For over 2 decades, the Hubble Space Telescope has diligently explored the deep field, although its vision has always been constrained by certain limitations. Hubble primarily operates within the visible spectrum, thus explaining its constraints, primarily caused by redshift, which affects its ability to detect infrared radiation. The telescope's vision is mostly blind to the presence of infrared radiation, which is essential for discerning the presence of exceptionally old galaxies and stars. As objects traverse further away in the ever-expanding cosmos, their velocity amplifies, causing their emitted light to shift toward the red end of the visible spectrum. This phenomenon is responsible for stretching the wavelength of light, rendering it observable in the infrared spectrum, a domain that remains hidden from Hubble's view, but accessible to the Webb telescope. Over a span of 10 days, a dedicated team of astronomers harnessed the power of Webb's near-infrared camera, NIRCam, to meticulously survey the deep field area, leading to the serendipitous discovery of 4 ancient galaxies. The distinctive redshift signatures revealed by these galaxies unveil their remarkable antiquity. with ages spanning from 320 million to 350 million years after the Big Bang. While redshift is a significant indicator of the galaxy's age, their elemental composition emerges as a crucial factor in deciphering their ancient nature. During the early cosmos, elements such as oxygen, carbon, and nitrogen, essential building blocks of today's universe, had yet to form, originating exclusively from the explosive demise of nascent stars. It is through the absence of heavy elements and metals, coupled with an extraordinary redshift, that the true antiquity of a galaxy is discerned. To deepen the understanding of these ancient entities, the near-infrared spectrograph, NIRSPEC, a pivotal component of the Webb telescope, was deployed to analyze the chemical signatures of these galaxies, confirming their ancient identity. The galaxy's composition primarily consisted of ultralight hydrogen and helium, marking them as the earliest, most ancient galaxies ever captured by human observation. The recent accomplishments extend beyond the realm of scientific inquiry, serving as a testament to the universe's luminous past, illuminating a stage when countless stars ignited, ultimately shaping the foundations for the birth of planets. Identifying an ancient galaxy goes beyond the simple detection of redshift. The absence of heavy elements and metals is a telltale sign of a galaxy's remarkable age. Utilizing the near-infrared spectrograph, researchers meticulously examined the chemical fingerprints of these galaxies, providing robust evidence of their early origin. The chemical analysis confirms the prevalence of hydrogen and helium within these galaxies, solidifying their distinction as the most ancient and primordial cosmic entities ever observed. Spanning a duration of 28 hours over 3 consecutive days, the captured infrared spectra showcase an unprecedented level of delicacy, offering insight into a distant epoch when the universe was illuminated by countless stars. Beyond its scientific significance, this achievement reinforces the notion that the universe was ablaze with starlight 13.4 billion years ago, playing a crucial role in the creation of the fundamental building blocks that eventually gave rise to planets. Although the newly discovered quartet of galaxies holds the title of being the oldest known to date, this revelation does not necessarily imply that they reign as the ultimate ancient galaxies in existence. The James Webb Space Telescope embarks on an ambitious mission to peer into the unfathomable depths of space, promising unparalleled revelations about the formative stages of the cosmos. Additionally, the telescope delves into the mysteries of intriguing worlds within our own galaxy, as well as exploring the very planets nestled within our solar system.
The Webb telescope can look at light that's been stretched, much more stretched than Hubble. And if you want to look far out into the universe, which means far, far back in time, then the further out you look, the further back in time you go, and the more stretched the light. And so the Webb is able to look at the formation of the first stars and the first galaxies. It's much more sensitive to the light from the most distant objects in the universe. If you think about it, if you look at something from which the light has been traveling 13 billion years to reach us, let's say, then you're looking at things as they were in the first billion years in the life of the universe. So the Webb, first of all, is going to look at the formation of the first stars and galaxies. It's also powerful enough to look at exoplanets, so planets around different stars. So the Webb is going to be able to look at planets that we've discovered around distant stars and tell us whether the atmosphere has water vapor in it, or is that it would see a planet with oxygen in the atmosphere. So the Webb is tremendously exciting.
A remarkable discovery has been made by the James Webb Space Telescope. An active supermassive black hole has been found, boasting a colossal mass 10 million times that of the Sun. This gargantuan cosmic entity is actively evolving, voraciously consuming matter from its surrounding cosmic surroundings, thereby sustaining its growth. A groundbreaking revelation emerges as the earliest growing supermassive black hole ever documented, originating a mere 570 million years after the explosive event that marked the birth of the universe, known as the Big Bang. While the researchers hold the hope that this record-breaking discovery may be surpassed in the future, the significance of this finding remains undeniably profound. The supermassive black hole's discovery took place within one of the universe's initial galaxies, previously identified as CEERS 1019, later referred to as EGSC 8P7. A significant stride has been taken in unraveling one of the universe's great enigmas, the rapid evolution of black holes during the cosmic dawn, a period characterized by the early stages of the universe. Larson states, "We've identified the most distant active galactic nucleus, AGN, and the most ancient black hole ever encountered." Larson's investigation into the luminous emissions of star formation in the ancient cosmos led her to delve into CEERS 1019. The radiance, referred to as LYMAN alpha emission, is attributed to the ionization of neutral hydrogen during the epoch when light struggled to traverse the early universe. The light remained confined within a haze of neutral hydrogen until ionization allowed it to propagate unhindered through space. Despite remarkable progress, much remains to be unveiled regarding the epoch of reionization, a pivotal period marked by transformative changes in the universe's fundamental nature. While peering deeply into the universe is an intricate endeavor, the consensus is that the epoch of reionization transpired within the initial billion years following the momentous Big Bang event, which unfolded 13.8 billion years ago. Galaxies such as CEERS 1019, which radiate relatively intense light, provide valuable subjects for inquiry, granting researchers an opportunity to unearth valuable insights. The discovery of this galaxy traces back to 2015, captured within Hubble's data, and stood as the oldest and most distant galaxy on record at the time. The nature of the universe's expansion has caused the earliest light to transition significantly into the infrared spectrum, necessitating the employment of advanced infrared instruments like JWST for their study. Subsequent observations solidified its existence, yet certain specifics continued to remain veiled in mystery. Consequently, when the JWST entered the scene, CEERS 1019, possessing remarkable brightness among the Hubble galaxies from that era, emerged as a prime candidate for investigation. With the combined capabilities of its four instruments, the telescope scrutinized the galaxy for a brief duration of merely 1 hour, generating a wealth of invaluable data. However, the story took an unexpected turn. Researchers discerned a distinctive emission signature associated with AGN, or active galactic nucleus activity, adding an intriguing layer of complexity. Intriguingly, these new insights prompted engagement with researchers specializing in AGN, enhancing the intrigue surrounding the interplay between star formation and AGN in the early universe. In the primordial cosmos, galaxies typically radiated either AGN emissions or the light produced by burgeoning stars. The concurrent presence of both phenomena within a single galaxy defied expectations and introduced a fascinating conundrum. Conventional understanding would dictate the prevalence of one or the other, but not both. Despite the influence of the black hole on observable emission lines, the star-forming domain within the galaxy remains the predominant source of the luminous radiance captured in the images.
The unanticipated revelation of a supermassive black hole expanding more than 13.2 billion years ago within the nascent universe adds an intriguing layer of complexity to cosmic history. The cosmic narrative has witnessed even larger black holes, such as the QUASAR galaxy, J1342 plus 0928, harboring a supermassive black hole estimated to be 800 million times the mass of the Sun, discovered 690 million years after the Big Bang. J0313 1806, a black hole of 1.6 billion solar masses, emerged 670 million years after the Big Bang. In both of these cases, AGN radiation holds sway. CEERS 1019, among the Hubble galaxies, straddles an intermediate stage, offering glimpses into the transition from AGN-dominated galaxies to the colossal entities we observe in later cosmic epochs. Rebecca Larson of the University of Texas at Austin, who led this discovery, says, "We seem to have identified the forerunner, or the entity from which these incredibly massive quasars emerged." The perplexing question of how these black holes achieve such colossal sizes in the early universe continues to captivate scientists. Researchers posted that CEERS 1019's supermassive black hole may have originated from the collapse of a massive object, conceivably one of the earliest stars in the universe. This black hole would have enjoyed an advantageous head start due to the substantial size of the stars during that era, far exceeding the stars present in our contemporary cosmos. Nonetheless, a helping hand was likely needed to facilitate its remarkable expansion. The concept of repeated super-Eddington accretion emerges as a plausible mechanism. The Eddington limit dictates the maximum sustainable rate of a black hole's growth. This limit is relevant as a surrounding disk of material spirals into the black hole, akin to water swirling down a drain. When the material surpasses the Eddington limit, its velocity becomes excessive, propelling it away from the black hole and into space instead of orbiting around it. While super-Eddington accretion transpires in short bursts, simulations propose that it could have occurred intermittently, facilitating the expansion of the black hole within CEERS 1019. Gaining a more comprehensive understanding of these intermediate galaxies is crucial in unveiling their intricate evolution, setting the stage for future discoveries. As Larson emphasizes, the initial findings are based on a mere hour of observation, suggesting a rich realm of potential revelations waiting to be unveiled. A dedicated effort is underway within the framework of the Webb project, aptly named JADES, as it embarks on extended observations of deep space throughout the year. The prospects are promising, hinting at the forthcoming emergence of hitherto unimagined perspectives and insights into the enigmatic cosmos. The James Webb Space Telescope, through its deep space gazing, unveils a realm previously inaccessible, enabling a thorough exploration of this particular juncture in cosmic history. The rapid appearance of black holes in the early universe remains an unsolved puzzle, and the search for primordial black holes continues, evading definitive resolution thus far. Two primary explanations underpin the profusion of black holes in the present-day universe. They either originate from massive stars that formed more swiftly than contemporary stars, or they arise from the abrupt collapse of intensely dense gas clouds. These prolific cosmic entities could have originated from either the rapid formation of giant stars or the sudden implosion of a dense gas cloud, each scenario contributing to the present-day abundance of black holes. The latter hypothesis posts it that the direct collapse of a substantial mass of matter within a galaxy led to the formation of a black hole, a process that necessitates less time. While this possibility is less likely, it holds the advantage of a shorter formation timeline, a crucial factor considering the limited time span available for such processes. The collaboration between the scientists and the team behind the MIRI instrument is set to intensify, with the aim of uncovering a more pronounced signal emanating from a distant galaxy. The emissions captured could potentially offer insights into the origins of the enigmatic black hole situated at the core of the galaxy. Furthermore, the presence of the supermassive black hole at the galaxy's center may be accountable for the enigmatic halt in star formation witnessed in the earliest galaxy ever observed, GS 9209. This cessation of star formation occurred suddenly, extinguishing the birth of new stars between 600 million and 800 million years after the Big Bang. A fascinating revelation emerges from the study of galaxy GS 9209, which experienced a period of exuberant star formation, producing the majority of its stars before abruptly ceasing this activity over 12.5 billion years ago. The intriguing aspect lies in the timing of this cessation, occurring astonishingly soon after the epoch of the Big Bang. The abrupt termination of star formation in the ancient galaxy GS 9209 shortly after the Big Bang is a particularly astonishing revelation. Larson underscores, "We speculate that a substantial portion of large galaxies in the local universe experienced a gradual decline over billions of years." Given its relatively young age, the constrained time frame makes the slow quenching process less plausible. The notion of discovering such objects was long deemed improbable due to the constant speed of light through the vacuum of space. The quest for deeper insights into the past propels scientists to explore the cosmos further and unveil more distant aspects of its history. The early 2000s marked the discovery of GS 9209, a significant addition to the ever-expanding roster of galaxies under study. A thorough analysis of the galaxy's emission wavelengths using ground-based observatories led astronomers to suggest the possibility of quenching in GS 9209. Over the past 5 years, however, Earth's atmosphere hampers the observation of crucial infrared wavelengths required to ascertain the galaxy's age, necessitating the deployment of a high-powered space telescope. The remote galaxy GS 9209 erupted into existence just 600 million years after the Big Bang, undergoing a spectacular burst of star formation within a mere 200 million years, equivalent to 40 billion solar masses. The James Webb Space Telescope's investigation reveals the galaxy's extraordinary burst of star formation, resulting in the generation of an astonishing 40 billion solar masses worth of blazingly hot stars over a remarkably brief 200 million years. The galaxy's stellar frenzy, however, ceased abruptly 800 million years after the Big Bang, underscoring the dynamic and transient nature of cosmic phenomena. The early universe's turbulent environment, combined with the galaxy's rapid formation, contributed to an exceptionally efficient and accelerated star-forming process. The rapid evolution of stars within GS 9209 was influenced by a unique interplay between the galaxy's surroundings and its intrinsic properties, fostering an environment of heightened star formation. The enigmatic narrative deepens as researchers speculate that the supermassive black hole lurking at the heart of GS 9209 played a decisive role in its sudden cessation of star formation. These supermassive black holes, formed through the collapse of massive stars, persistently devour matter, including gas, dust, stars, and other black holes, as they grow and evolve. The black hole residing within GS 9209 may have expanded sufficiently to transform into a quasar, characterized by an accumulation of material spiraling into its core. The quasar's intense emissions, fueled by the heated material, manifest as bursts of light emitting brilliance far surpassing that of the brightest stars. A captivating tale unfolds as scientists eagerly await the advent of the Extremely Large Telescope, ELT, by the European Southern Observatory, scheduled for its inaugural observations in 2028. Promising an enhanced exploration of GS 9209. The journey has only just begun, with initial observations of the galaxy signaling the emergence of hitherto uncharted realms of cosmic inquiry and revelation. The year ahead holds a wealth of promise as the Webb project, known as JADES, embarks on extended observations of deep space, heralding a new era of discovering and understanding. Beyond unraveling the mysteries of distant galaxies, the James Webb Space Telescope has also ventured into exploring our own solar system, shedding light on the intricate details of planets within our celestial neighborhood. Among its many achievements, JWST has meticulously observed Jupiter's atmosphere, unveiling the complexities of its cloud patterns and atmospheric dynamics. This detailed scrutiny of Jupiter's atmospheric layers has provided insights into the planet's composition and weather patterns, enhancing our understanding of gas giants and planetary atmospheres. The telescope has also turned its gaze towards Saturn, captivating stunning images of its iconic rings and delving into the study of their composition and origins. These observations offer a glimpse into the intricate dance between the moons and rings, revealing the dynamic interplay that has shaped Saturn's rising system over eons.
Furthermore, the James Webb Space Telescope has honed in on Mars, analyzing its atmosphere and revealing the presence of various molecules, including carbon dioxide and water vapor. Such investigations contribute to our comprehension of the Martian environment and its potential for habitability, guiding future missions and explorations. In addition to planetary studies, JWST has cast its gaze beyond our solar system, delving into the realm of exoplanets, planets that orbit stars outside our Sun. The telescope's precise observations have enabled the characterization of exoplanet atmospheres, unveiling details about their composition and potential habitability. One remarkable achievement involves the detection of water vapor in the atmosphere of a distant exoplanet, further igniting curiosity about the existence of liquid water and the potential for life beyond our planet. The quest for habitable exoplanets continues, and JWST's capabilities are expected to play a pivotal role in identifying potential targets for future exploration. Beyond individual celestial bodies, the telescope has also probed the vast cosmic web, the intricate network of filaments and voids that comprise the large-scale structure of the universe. By studying the light from distant galaxies as it travels through this cosmic web, scientists gain insights into the distribution of matter and the forces shaping the universe's evolution. The cosmic web's tendrils are thought to be responsible for guiding the growth of galaxies and influencing their interactions over cosmic timescales. JWST's ability to observe distant galaxies in unprecedented detail has allowed researchers to trace the intricate paths of light through this cosmic framework, revealing fresh insights into cosmic evolution. An exciting development involves the discovery of distant galaxies with exceptionally bright and powerful bursts of light, known as gamma-ray bursts. These high-energy events, believed to result from cataclysmic processes like massive star explosions or merging neutron stars, offer a unique window into the universe's most energetic phenomena. The telescope's observations of gamma-ray bursts provide valuable data for studying the underlying physics and extreme conditions associated with these colossal cosmic events. As the James Webb Space Telescope continues to peer deeper into the cosmos, astronomers eagerly anticipate the potential discovery of even more gamma-ray bursts, unraveling the mysteries of their origins. Beyond its astronomical achievements, the JWST has sparked a renewed sense of wonder and curiosity among people around the world. Its breathtaking images and groundbreaking discoveries inspire scientists, educators, and the general public alike, igniting a passion for space exploration and the pursuit of knowledge. The telescope's educational impact is far-reaching, encouraging the next generation of scientists, engineers, and space enthusiasts to embark on their own journeys of discovery. Through its ability to capture the beauty and complexity of the universe, JWST serves as a powerful tool for fostering scientific literacy and inspiring a deeper connection to the cosmos. The James Webb Space Telescope is not only a technological marvel, but also a testament to humanity's insatiable quest for understanding. Its journey through space and time has allowed us to peer into the distant past, witness the birth of stars and galaxies, and uncover the enigmatic secrets of the universe. So that's what we've got for you on this video. I suppose you enjoyed watching it. Give it a like and share it with your friends. We appreciate your support.